This is the Lexer section of the series, and what a Lexer is something that groups similar characters into something called tokens. And these tokens will make it easier for us to make a language out of them, a programming language out of them. And the way we're going to go about doing that is we're going to loop through all of the characters, starting from the left, and whenever similar types of characters, like letters for example, we're going to keep marking them off, and we're going to group them into a single string. And once we switch from letters to whitespace, for example, or an operator, it's going to treat this as one big token and save it to our list. So once we have if marked out, we're going to add it to our list of tokens, and then we're going to keep going. This space character would be its own token, and then we'd be done with that. Same thing with this parenthesis. There's only one parenthesis right there, so it'd be grouped in its own thing. And we'd keep going until we get to these double equals. One thing that we're going to do to make this a little bit more useful is that we're going to not just group characters together when they're operators. We're going to try to match them from a list of known operators, and if it's not able to find that, then it's going to throw an exception. This is to help us with things like somebody putting a minus sign there without any spaces at all. If we didn't do this, this would be one big token, and we don't want that. Alright, so first I'm going to make a Java project. I'm going to use Eclipse. You can use whatever you want. Call the project Tokenizer. I'm going to go ahead and make a Tokenizer class. Now I'm going to make a method that will look at the very beginning of our input, figure out what token is at the very beginning, and then chop that off of the input. So if there's like 1, 2, 3 at the beginning of our input, it's going to read that and chop it off, and then read whatever's next, like another number or an operator, whatever it is. This is the marker that's going to represent where we are, like how much we've cut off and stuff. This is going to be the token that's currently at the beginning of what's left after we've marked off whatever. So this is going to keep changing to number if 1, 2, 3 is at the front, or operator if something like equals is at the front. Now we're going to write what type of, or the code that actually identifies what type of token is next. So this is the character at the marker, and from that we're going to try to determine the token type which we're about to make. Alright, so I think it'll be useful to make this an enum, so let's go ahead and do that. And we're going to have a few types. This is going to be like variable names and stuff like that. This is going to be real numbers with decimal points and stuff. It's just going to be operators like plus, minus, equals. We're going to have white space. That way it'll work with the existing code and we can just skip over all of the extra white space. And I think that's it. Let's go ahead and finish up the next token type thing. We're gonna want to group periods in with the the numbers, because something like this would be a number, and so would this, and we want it all to be grouped into one number. Now we're going to do white space. And we want to treat everything else as an operator. We're going to pass this off into a... Actually, no, we're just going to return our operator type. That'll be fine. Alright, for the next part, we're going to make it so that numbers and words, for example, fish and 1, 2, 3, are both red until it changes to something else, like white space. For white space, like new line characters, carriage returns, and spaces, we're just going to skip over those. And operators, we're going to match those from a big list. That way, something like x equals -5, even if we don't put a space there, is still handled as x equals -5. Alright, so first let's go ahead and start parsing identifiers and numbers. We're just going to read these from beginning until there's no more of whatever it is, identifier or number. Start off with an empty string, and we're just going to append all the things that we read in or cut off from the original input. We're also going to add a check to make sure this doesn't pass the end of the input string. And then we're actually going to insert this into the list of tokens. Next, we're going to handle white space. We're going to do the check again. And we're just going to ignore the white space. Otherwise, it's an operator. Next, we're going to make a list of different operators that are valid. And we're going to want the bigger ones to come first. That way, something like plus doesn't get checked before this, because this could be two of these, and we want it to be just this, not two of these. So we're going to put the big ones first. First version's only going to support a few operators. Now we're going to go through each of the operators and check if what's at the front of input is one of these operators. This part right here only keeps the stuff after the marker, so it keeps our place, and then that way we only check the beginning of that against each of these operators. And whenever it finds one, it reaches this part, and we're going to break out. But before we break out, we're going to also add that to our list of tokens. Okay. It's got to be a token, not a string. Now we're going to make an operator type class, and it's just going to keep track of the token type and the token value. Also want some getters for this. I'm going to rename these to just get type and get value. Alright, last thing we're going to do is we're just going to make sure it all works together. So I'm going to make a main method real quick. Here's our list of tokens that we're going to print out. Just going to make a temporary object for this. Okay. Alright, let's go ahead and try that. Looks like it's working with identifiers, numbers, and operators. The next thing we're going to work on is string parsing. I forgot to do that earlier. So first we're going to add that as a token type. And now we're going to make it so that it's part of the things that check for the next token. Next we're going to add it to the thing that actually chops off the next thing. We want it before operator, because operator is like a catch-all. For this one, we're just gonna keep appending to the value until we reach the second quote mark. So we're gonna want to start off right away with one marker increment because it's currently at a quote mark right now, and we want to take everything in between the quotes. So while it's not the ending quote, we're just going to do token value plus equals the character at the marker. We also want to increment the marker after adding it to the token value. And we just add the new token. go ahead and test it. Let me look for the error. I'll be right back. Alright, so there was two issues with it. The marker needs to be bounded to the end of the input. And also, whenever this loop finishes, it leaves the marker at the ending quote, and we need to skip over the ending quote so that it'll be onto the next thing that it needs to read in. Alright, let's add a few things to check for exceptions. Right here we're going to check to make sure there was an ending quote and it didn't just reach the end of the input. So we're going to do check if the character where we stopped at before we change it is equal to the ending quote, or if it's not equal to the ending quote, we're going to throw a new exception, runtime exception, and it's going to say missing ending quote. We're also going to add an invalid operator message. So we assume we didn't find one until we do. And if we don't find one, we throw a runtime exception. And we'll just give them the next character so they have an idea of where the operator exception's at. One last change. Instead of checking to see if the ending character wasn't a quote, we need to change that to marker is equal to the end of the string. Not going to be able to check. There's nothing. Or, yeah. Alright, that's it for the tokenizer. In the next part, we'll be talking about how to make a tree builder where we take all these tokens and make a tree out of them. And eventually, in the last part, we'll be able to take that tree and actually evaluate it and actually do stuff. I'll see you in the next video.